Hi, Mr. Gazda here. This is one type of review for the Earth Science Regents exam. When I was a kid and I was taking Regents exams, I would get a book like this and do a lot of studying from it. What this has is it has old Regents exams in it, and I would do the questions right in the book. It also has the correct answers, so I would check my answers. But more importantly, it had explanations for each question of why the correct answers are correct and why the wrong choices are wrong. So that was really big. But what I found with earth science over the years is if it's a question or a topic that is challenging for you, sometimes reading the written explanation can be really confusing because earth science is very visual. There's a lot of diagrams, there's the reference table, so sometimes it's not as helpful as it could be. So I've decided to use the power of video to be able to show and explain and use a lot of diagrams to explain the correct answers. And that's what this video is. So this is how it works. You sit down and on your own you do the multiple choice for the June 2018 Regents exam. If you don't have a copy of it, there's a link in the description. Then you check your answers with the answer key. If you don't have one of those, also in the description you can get a link. And then for the ones that you get wrong, and you're going to get some wrong, you actually may get a lot wrong. Don't worry about it. This is a hard test and you're just in the process of studying, so don't worry about the ones you get wrong. You want to not get them wrong next time and then on the final test. And to do that, what you should do is for all of the questions you get wrong, below in the description there's timestamp links. If you click on it, it will take you right to the explanation for that question, and do that for all the ones that you get wrong. And I think this can really, really help. In addition to this video, I have some more Regents Review as well in the form of online Regents Review courses. I have a free course and then I have a more comprehensive paid course. The link to those is also below, and it's on my website, gazdoniproductions.com. So work hard, study hard, and that will guarantee that you do your very best. Good luck. Welcome everybody, June 2018 Earth Science Regents exam. I'm Mr. Gazda. Today we're going to do the multiple choice 1 through 50. Here we go. Question 1. The photographs below show two types of solar eclipses. Letter A and B represent two celestial objects. Okay, so it's A here, B is the black, and A is here the white, and B is the black. Partial solar eclipse, total solar eclipse. So first thing I'd like to do is show a diagram of kind of what's going on here. So here we have the sun and the moon and the earth, and in this case these are solar eclipses in that the moon is blocking out the sun for those people who are on earth. So solar eclipse, the sun is blocked out. I like to think whatever the name is there is the eclipse of the sun. So then you know that the sun is blocked out. So if you are right in that spot right there, you are experiencing a total solar eclipse. Anywhere else is a partial solar eclipse. This shows some stages of a solar eclipse, for instance. This is a total solar eclipse. These are all partial leading up to it. This is also from a Regents exam, another diagram that you might see. The other type of eclipse would be a lunar eclipse, not what we're seeing here, but that is when the moon goes into Earth's shadow. So this would be Earth's shadow in space, and then the moon is in Earth's shadow, eclipse of the moon, and then the moon is kind of blocked out. But that's not what this is. It's a solar eclipse. And therefore the answer is choice 3. A is the sun and B is the moon. So you need to know something about solar eclipses in order to answer that question. Number 2, here we go. Compared to the terrestrial planets, the Jovian planets, and here are your choices. First off, you need to know what is meant by the term terrestrial planets and Jovian planets. Well, the terrestrial planets, terrestrial means Earth-like. They are the 4 inner planets. They have rocky surfaces. The outer 4 planets are called the Jovian planets. So make sure you know that, commit that to memory, because those terms are not in the reference table. So once you know that, then you do go to the reference table, page 15. And here I've highlighted these are the terrestrial planets and these are the Jovian planets. And then you're just comparing your choices here, which are revolution, period of rotation, mass, and density. The period of revolution is a little tricky here in that it has orbital velocity, so you need to be able to figure that out. But looking through the chart, your answer here that you will get is the Jovian planets have shorter periods of rotation. Number 3, which event occurred more than 10 billion years ago? Here are your choices. What I'm going to show is a timeline here to give you some perspective. So if this is now, we're going back in time. The Big Bang, which was started the universe, occurred in the 13 to 14 billion years ago. The solar system begins about 4.6 billion years ago. And the solar system, the sun, the planets, Earth all started here. So anything else that happened on Earth, any evolution is all going to occur in here. Therefore, you have to know this, have some perspective on it. And your answer here is going to be choice 1, the Big Bang. Question number 4. In 1851, French physicist Leon Foucault used a swinging pendulum to demonstrate that Earth did what? So, Foucault pendulum. I hope that you've seen some sort of diagrams or demonstrations of this already, but this is a diagram of what it looks like. And basically the Foucault pendulum, it kind of swings back and forth in a straight line, but over time it appears to be moving compared to the floor. And that is because the Earth is rotating beneath it, which is crazy. It's an experiment that proves Earth rotates. Foucault was not messing around, people. But anytime you hear or you see Foucault pendulum, know that that proves that Earth rotates on its axis, okay? Therefore, the answer here is choice 1. It proves that it is rotating. Question 5. Approximately how many degrees does Earth travel in its orbit in 1 month? And like degrees of arc of a circle, think of right all the way around is 360 degrees. That's what they're getting at. So let's look at this. This is a diagram showing Earth revolving around the sun, not the scale. And what I want to say is, for instance, from Earth to go from D to A to B to C back to D, that whole revolution takes 1 year, okay? And then it's interested, the question, if you look back at the question is in 1 month, how many months are in a year? 12. Therefore, it goes 360 degrees in 12 months. So if you were to do that math, what you get is this. It revolves 30 degrees per month. So the answer here is going to be choice 3, 30 degrees, because it does say 1 month there. Question 6, a weather question. Here we go. What is the relative humidity when the dry bulb temperature is 16 degrees Celsius and the wet bulb is 10 degrees Celsius? You need the reference table for this. Here we go. You need to make sure that you are on the relative humidity chart of the reference table. And the key thing here that I've seen kids get wrong so much is that these numbers here are the difference between the wet bulb and the dry bulb temperature. They are the difference. So if we go back to the question itself, it says the dry bulb is 16, wet bulb is 10. Therefore, what is the difference there? It is 6. 16 minus 10 is 6. So we're looking into the column here for 6. I'm going to highlight it. Okay, and then you want to match up the dry bulb temperature given in the question is 16. So I'm going to draw that in there. Where they meet, that is going to give you the relative humidity as a percent. That is how full the air is with water vapor. It's 45% full of water vapor, and that is going to be choice number 4. So that's the answer. Question 7. Boarding up windows would be one emergency action most likely taken to prepare for which natural disaster? Let's just review some of the main preparedness actions for natural disasters. So, an earthquake, some of the main ones: get under a strong table right away and away from falling objects. Hurricanes, get to high ground, board up windows, make sure you have canned food, weather radio, generator, and there's many more, but those are the main ones. For a flood, get to high ground. Tsunami, also evacuate to high ground. Therefore, based on that, the best answer here is hurricane is the disaster in which you board up windows. Question 8, jet stream question. Which diagram best represents the general position and direction of flow of the polar front jet stream in the northern hemisphere during the winter months? Okay, this is kind of tricky. There is reference to the jet stream on the reference table. This is page 14. This chart tends to drive kids kind of crazy. This is the jet stream here, and it's represented coming out of the board and into the board. But you can't really tell that direction based on this. Okay, so that's not really going to help you. You kind of have to know this. So this is a diagram showing a typical winter polar jet stream, how it kind of comes down from the north like this. And it's always in this direction. Over the U.S., the way the prevailing winds always go is always from west to east. So your answer here is going to have to definitely be in that direction. And this is the best answer, choice 1. These go in the wrong direction, okay, so it's definitely not those. And 2, while it's going in the correct direction as far as west to east, it is so much, so close to the equator, and it is asking about the polar front, which is going to be closer to the pole. So that's why it ends up being choice 1. Number 9, moon question. The diagram below represents 4 positions of the moon, A through D, as it orbits Earth. Okay, so then it has the choices here of what it would look like. This is one of the trickier moon questions, okay? So the first thing I like to recommend is draw in these red lines here that represent what you can see from Earth. So if you're on Earth, what do you see of the moon? You see mostly dark, a little bit lit up on the right. Now you see half and half lit and dark. Then it's mostly lit. Here you see it all lit. Now hopefully you were able to sort of, be able to synthesize that in your brain to then apply to these choices. And again, this is a little bit tricky. Therefore, using that knowledge and using that diagram there, and feel free, definitely write on the test. Okay, if you have it in front of you, definitely do this stuff if you need to. I often have draw a little person in there to give you perspective of what it looks like. And therefore, of these choices, the best answer is going to be choice 4. Question 10. The diagrams below represent spectral lines of hydrogen gas observed in a laboratory and the spectral lines of hydrogen gas observed in the light from a distant star. Okay, these questions I found over the years to be very confusing for kids, so if you're confused by it, don't worry too much about it. I'm going to explain it now. So this is showing the spectral lines of hydrogen seen through a device in a laboratory. And basically, these are the way that the light sort of will spread out into these lines here. In a lab, that's what you see. When you look out into space and you see light from a distant star of hydrogen, it is now like this. So it's the same exact order and pattern, distance from each other, just all of it is moved this way towards the longer wavelength. Okay, that makes it a little more tricky. So it's shifted towards a longer wavelength. Now let's get to the color that's representing. Okay. But before that, and if anything moving toward Earth, the light is shifted towards the blue because the wavelength will be compressed. If something's moving away, the light is shifted towards the red because it's stretched, because red is a longer wavelength, as we're going to see here. So this is decreasing wavelength, they're shorter, increasing wavelength over here towards this side. So of visible light that we can see, the colors that we can see, the blue is shorter wavelength and the red is longer wavelengths. So if you then go back to this question here, longer wavelength, it is shifted towards the longer. We call that the red shift, and that is what we see when we look out into space at distant galaxies, or distant stars in this case. We see all of that is shifted towards the red, again, the red shift. And that proves that everything in space is moving away from us, or the universe is expanding. Therefore, the answer here is choice 2, red end of the spectrum indicating the stars moving away from Earth. Question 11. The diagram below represents a cross-sectional view of the plane of Earth's orbit around the sun. A line drawn perpendicular to the plane of Earth's orbit is shown in the diagram. Okay, so there's a lot here. You really got to look and see what's going on here. So obviously this line doesn't exist in space, but this is a perpendicular line between the sun and Earth, and this is a perpendicular line to this. So it's really about Earth's axis. You have to know something about Earth's axis and its tilt, because it asks how many degrees is Earth's rotational axis tilted with respect to this line shown in the diagram. So you have to know this. If this is that orbital plane drawn in here, and this is that perpendicular line shown in the diagram, Earth's axis is really like this. Here's the North Pole drawn. It is 23.5 degrees, this angle. That's what the tilt is, 23.5 degrees from perpendicular. That's not in the reference table. That's something that you need to know, so commit that to memory. And therefore, that will get you, and I drew it in here. So this here is 23.5 degrees if I was to draw this in, and therefore it gives you the answer of choice number 2. Number 12, the large white dots in the diagram represent stars in the constellations Scorpius and Orion. Information indicating when these constellations are visible from New York State is provided below the diagrams. So this shows it's visible in July, not visible in January. This shows it's visible in January, not visible in July. Now, the question here is basically saying why are they visible at different times? So let's look at this first and try to explain it. So if this shows sun and earth revolving around it, what this diagram is trying to show is way out in space where these different constellations are. So if earth is here, we only can see these stars at nighttime, right? So what's constellations would you be able to see when you're on earth at night? Well, Gemini is a really good one, and maybe you can see Cancer and maybe Taurus. But that's what you see at nighttime. You will not be able to see these constellations in this section of space because you'd be facing them during the day. And when you're over here, you would then be able to see these constellations at night. And that's why you see different constellations during different times of the year. I often like to say, Earth at night is facing different sections of space at different times during the year, and therefore you see stars in that section that your nighttime Earth is facing. So therefore the answer here, the best answer here is choice 3. The nighttime side of Earth is facing different parts of our galaxy as Earth orbits the sun. 13. Which table correctly shows the interior temperature, melting point, and the state or phase of matter of the materials located 4,000 kilometers below Earth's surface? So you need the reference table for this. And this is actually one of the more challenging parts of the reference table, so bear with me here. Okay, so it is this page of the reference table, the interior Earth, okay? And it's labeled here. And all this relays down and goes down to this these two charts, which represents temperature and pressure, okay? So first thing you want to do is find depth of 4,000 kilometers, which I've highlighted here in red. Now we're going to zoom in a bit so we can see it better. So this is 4,000 kilometers, and you want to know the temperatures of the interior temperature and the melting point, and whether it is solid, liquid, or gas. So what we're going to do is really look closely here. So this dark line is the actual temperature of Earth, and then the dashed line represents the melting point of that type of rock that's down there. So let's see here, let's try to get some numbers on these as far as temperature goes. So this right here would be the interior temperature line. I'm going over to here, okay? So it's between 5,000 and 6,000. And then the melting point is going to be right here. I labeled that. So in this case, look, this is the actual temperature and this is the melting point. So the temperature is higher than the melting point. And you have to be able to decipher in your head that that means that it would have melted because it's hotter than the temperature it melts at. So it's going to be liquid there. That part of Earth is going to be liquid. And then it asks the temperatures here. So this, we estimate, is maybe, I think it's 5,700, and this is about 5,400 Celsius. And therefore, that is how you get this choice here. Interior temperature 5,700, melting point 5,400, and the state of matter, that section of inner Earth is a liquid. It's definitely one of the more challenging questions for students using that chart of the reference table. It's not that easy. Number 14. Which gas is a greenhouse gas that has increased in Earth's atmosphere partly as a result of deforestation over the last 100 years? Deforestation means cutting down of trees, cutting down of forests. So here are your choices. First, I want to go through what are some of the main greenhouse gases, and they are carbon dioxide, CO2 is the chemical formula, methane, CH4, and water vapor. Now, let's look at the choices. Which of those in the choices? It is going to be carbon dioxide. So that is something important to know. Number 15. Which ocean current brings warm water to the southeastern tip of Africa? Here we go. You need this page of the reference table. Absolutely need to know it's there. Here we go. This is the ocean current page. Please note to key the warm current and cool currents. Now what you need to do is you need to find the southeastern tip of Africa. It involves your knowledge of geography and or just looking around, but you're going to find it over here. Okay, I have it in that box. Let's zoom into that box because that is where you're going to need to look. So we zoom in here and it's talking about what's going to bring warm ocean currents to the southeastern tip of Africa. That's the answer right there. The Agulhas current, which you'll see is answer number 2. Number 16, which pie graph is shaded to best represent the approximate percentage of time that humans have existed during Earth's entire history? Okay, check this out. Now, you can look at the reference table for it. Humans are right in here, it says early humans. Now, first you need to be able to understand this. This is the centerfold of the reference table. It's pages 8 and 9. So basically, if the red here is the timeline of Earth's history. This goes back 4.6 billion years ago, and then this is more recent. This is today. Now, what you see here is this little bit of time here, the last 550 million years about, is all then expanded out to this section of the graph. So basically, so much has happened that we're interested in this little time frame here, they expanded it out. So that's kind of how this works. And of this whole area, you can see, of all of this, humans are right here. Therefore, what that means is that on this timeline here, humans are just like right there. Pretty crazy to think about. So here is a different timeline that I have from another Regents exam. Basically, this is Earth's beginning 4.6 billion years ago, and then this is today. Now, of these 4 letters, which one represents the earliest humans, or when humans came about? And it is D, which is pretty awesome. So basically, we're right near today, and that gives you a good sense of scale. And New York State really wants you to know that. So this comes up in Regents exams. Therefore, the pie graph answer to this is going to be choice 1. 17. Volcanic ash can be used as a time marker to correlate rock layers because the ash, well, correlate means to match up. In this case, we're matching up different rock layers that formed at the same time or are of the same age. This is an example of it here. So here, the black, it represents a volcanic ash layer. Okay, and basically these ash layers come from huge eruptions that send ash out into the atmosphere and carry it all around Earth, and then it will settle down to Earth and be deposited. So it is a very good time marker. I've heard it often described as like taking like a sheet of plastic and wrapping it all around Earth at the same time is what this volcanic ash layer is. So what did I write here? Volcanic ash layers help us to correlate rock layers because ash from a huge eruption is deposited all over Earth at the same time. So it is a really wide geographic spread because it gets up in the atmosphere and kind of will settle out, and it can go all over Earth. So that is why it's a good time marker. Therefore, the answer is choice 1 is deposited rapidly over a large area. 18, the cross section below represents a mountain range. Points A and B represent locations on Earth's surface. A and B is over here. Prevailing wind, that means the wind generally comes from that direction, has the arrow there showing it. Question is this: compared to the climate of location A, the climate of location B is what? So first, let's see what's going on here climatologically. So when the wind is coming this way, what happens? The air will rise over the mountain. As it rises, it will have less air pressure, so it will expand and cool, therefore getting closer to its dew point. It will then reach its dew point, clouds will form, and you have precipitation here. So it's going to be wetter and it's going to be cooler. So in the summertime you have rain. If it's a cold climate, you'll have a snow. This is why mountains get a lot of snow. And then what happens here is once it's dumped a lot of its moisture, now you have drier air coming down, and the reverse happens. It will then compress. That causes it to adiabatically warm, if you've heard that word. And because it has less moisture in it, it's going to be much drier here. So in this instance, when there's a mountain range, it's going to be wetter and cooler kind of here, and always warmer and drier here. We often have like major desert areas. Think of Death Valley, California is in this situation. Therefore, the answer to this is going to be choice number 4. B is going to be warmer and drier than A. Number 19, the photograph below shows conglomerate composed of pebbles cemented together with calcite. This is the diagram. This is the question. Compared to the ages of the calcite cement and the conglomerate, the relative age of the pebbles is, well, first, just as a bit of a reminder, relative age always means compared to. What did I write? Age compared to something. So it's not Absolute age would be ages in years. But basically, in this rock here, these are the pebbles, and then it's held together by calcite cement, and then it's talking about the rock itself. So the pebbles had to exist first for them to end up being deposited, cemented together with calcite, and forming this rock. So the pebbles have to be older than both the calcite cementing them together and the rock that they form themselves. Therefore, the answer here is the relative age of the pebbles is 3, older than both the calcite cement and the conglomerate. Number 20. Cross-section below represents some parts of Earth's water cycle. A, B, and C, and D represent processes that occur during the cycle. And now you're just trying to match them up. Let's do a little bit of review of some of the processes here. So some of these are more straightforward. You might have learned in middle school. You kind of know this stuff. Ocean, evaporation, condensation. Clouds are actually liquid water droplets. So it's actually water vapor becoming liquid in the clouds. So condensation happens in the clouds. Precipitation, rain, snow falling from the clouds. The things that are kind of newer and more challenging for students is transpiration. Transpiration is water vapor given off by plant life, and that goes into the air as well. That's the one you really kind of need to know. And then you have some of the stuff that happens in the ground. So when rain, let's say, hits the ground, it's going to do one or two things. It's either going to go soak into the ground. It's called infiltration. Or if it doesn't, it will then run off, let's say downhill, or if it's a parking lot, can't go into the ground, or the ground is saturated with moisture already. So you have runoff. So C is runoff. This is important to know. If you don't know it, study this, make sure you know it. And then it gives you the answer here is going to be choice 4. Okay. A is evaporation, B, transpiration, C, precipitation, and then D, condensation. #21, hope you like charts. Which table best shows the relationship between latitude and general climate conditions on Earth? Okay, so you absolutely need the reference table here. You do. So it's knowing what's on the reference table and when you go to the reference table and when you need to know it in your head and when you need to mix the two. That's important. So you also need to know that the word arid means dry and humid means moist. But arid means dry. If you don't know that, make sure you do know it. So this is the reference table, page 14. This shows like wind patterns on Earth. I zoomed in, and it has wet and dry areas labeled. So I have the wet areas of Earth are labeled with the blue, and then I highlighted the drier areas on Earth in this orange color. So you need to reference this, have this out in front of you, and then look through your answer choices of this question. And when you do that, this choice number 2 is going to be your answer based on page 14 of the reference table. Number 22, the photograph below shows different size rounded sediment. Okay, then the question asks, which table shows the most likely process and agent of erosion responsible for this rounded sediment? So it basically means responsible for the sediment being rounded. So this is where it gets a little tricky. Let's look at the first one. The process of sandblasting, agent of erosion running water. Well, something you need to know, and you need to know about something about sandblasting, and that's a wind. The process, the agent of erosion for that is wind that causes sandblasting. So right off the bat, those two don't match up, so 1 is not the answer. I'll go to 3. Process, landslide, mass movement. Well, a landslide is a type of mass movement. However, you don't get rounded sediments from it. For rounded sediments, you need a lot of abrasion, rocks tumbling, rolling into other rocks, sand hitting it for a long period of time. A lot of that needs to happen to round rocks. And when you have a landslide, maybe rocks will only fall a few hundred feet. The landslide has angular sediment, so it's not choice 3. Choice 4, process deposition and wind erosion. Well, deposition doesn't cause the rounded nature of it. It's a little confusing, but that's not it. So the correct answer here is choice number 2. The process that causes the rounded sediment is abrasion. Like I said, it's the tumbling into other rocks and sand hitting it, rubbing the edges of it. And the wave action is where that happens. Think of the waves, the rocks roll back and forth into each other. You get a lot of rounded sediment. Also get rounded sediments like with stream erosion is also pretty rounded. But this is the best answer for this question. Number 22, the photograph below shows an outcrop with two basaltic intrusions labeled A and B in a rock unit labeled C. What is the relative age of these three rock units from oldest to youngest? First of all, oldest to youngest. I often have to think slowly about that. Which occurred first to most recent. I often see kids who know this stuff get that wrong because they just get those jumbled. Take your time and go slow. Remember that. Next thing you want to know, relative age means the age compared to. So we're not talking age in years or no numbers with it. Just like which is oldest, then came next, then came most recent. Which you probably can tell from the answers. The other thing with this is, okay, so this is the rock unit, and then A and B cut across it. So here's an example here. I have a piece of paper, and what's the relative age of the fold in the piece of the paper compared to the paper? Well, the paper is older, and then the fold has to be more recent, right? The paper had to exist for the fold to go across it. The principle of cross-cutting relationships. So, for instance, C had to exist for B and A to then cut through it. So C definitely has to be the oldest. So what happens here, and hopefully you can see this in the photo, whatever you may have in front of you may be more clear, but basically you see C was here, and then A cut into C, okay, because there's igneous intrusion, and then you see how B then cuts across A. So A had to be there for B to cut across it. So B has to be the most recent. C is the oldest. So it should go C is the oldest, then A, and then B is the most recent. And that's how you get choice 3 for that one. 24. The world map below shows Earth's major tectonic plate boundaries. The letters A through D represent 4 surface locations. The question is this: which location is on a major rift valley? That, you need to know what that means, rift valley in the word. Let's go start with the word rift. Rift is basically a crack or split or break in something. In the world of plate tectonics, that rift is when you have plates pulling apart. Look at these arrows here. Plates pulling apart. In this case, a rift forms in continental crust when diverging occurs. Diverging plates. This is the sort of that rift valley as those plates pull apart. So that you need to know. The word rift you're not going to find on the reference table or anything. But what you need to then do is I took those locations that are on that map, and then I turned to page 5 of the reference table, and I tried to place them on there. And then I use the key down here. So I'm looking for a location where the plates are pulling apart, diverging plate boundary, pulling away from each other. And if you go through here, this is the middle of a plate. D, this is a transform plate boundary here where they're sliding past, so it's not that. B, you see the arrows there, they're moving together, that's not it. But A, right here, actually it has the word rift in there. So that's actually a good clue that it has the word rift. Therefore, it's going to be, the answer is going to be choice A. Choice 1, letter A. Number 25. You may look at this and go, ugh, all of the words and a bunch of numbers. I get it, but just take your time, go through it slowly, read it once or twice if you need to, okay? This is how it goes. 25, the first P wave of an earthquake took 11 minutes to travel to a seismic station from the epicenter of the earthquake. What is the seismic station's distance to the epicenter of the earthquake, and how long did it take for the first S wave to travel that distance? So, check this out. You absolutely need the reference table. So here we go. It says 11 minutes for the first P wave. Notice I am going slow. I need to go slow in my brain for this. So 11 minutes for the first P wave. Let's figure out how far away the epicenter must have been. So I'm going to zoom in a little bit here. So I drew a line from 11 minutes over to the P wave line, and then I'm going to draw one down, and that's going to tell me how far away the epicenter of the earthquake was from that seismic station. And you probably know this by now, but that's actually 7,000 kilometers, 8,000. That is going to be 7,600 kilometers. Okay, so that gives us the distance, and that narrows it down to just 2 of the choices. And now from here, how long did the S wave take to travel? So we're going to now do this. We're going to now, you see the S wave chart. We're going to go from 7,600 up to the S wave line, which is this right here, and then we're going to go over that way to the time where it shows over to the time scale, and that's going to be 20 minutes even. So that tells us 2 parts to this. It's the epicenter was 7,600 kilometers from the seismic station, and the S wave took 20 minutes to travel that far, which I have noted right there Therefore, the answer for this is choice number 4. One of the more challenging ones, if you had trouble with that chart, it's going to be one of the more challenging ones. So watch this again, do more of these, but you can get it. 26. The Catskills are commonly called mountains, but are actually part of the Allegheny Plateau. The Catskills are classified as a plateau because of what? So let's look at landscapes a little bit. So mountains, plateau, and lowlands. So mountains are high elevation with distorted rock structures. See this folding here and faulting. So the rock layers are really sort of all messed up, or we'll really say distorted, or have been altered somehow. A plateau is high elevation, but the rock layers are pretty flat. So it's been lifted up and remained pretty flat. Maybe you've seen like pictures of the Grand Canyon, for instance, are a good example of a plateau, in that the rock layers are really flat, though it is pretty high elevation. And lowlands are just usually pretty low, are kind of lowlands. It doesn't really apply here. So this is a good example showing something like the Grand Canyon. A plateau has high elevation, flat rock layers. You see the rock layers here. And that, they're saying in the question, that's what the Catskills are. And therefore, the answer you're going to get, it's called a plateau because of bedrock structure. And in this case, it's because it's flat bedrock structure. If they were distorted and folded and bent and faulted, they would be considered mountains. 27. The minimum stream velocity necessary to transport a sediment particle that is 0.1 centimeters in diameter is closest to which one of these? Absolutely need the reference table, page number 6. Here we go. And this is the chart here. And it has stream velocity here and has particle diameter here. So what are we looking for? We are looking for 0.1 centimeter in diameter. So that's going to be right here. And then this is the line, this is what gives us our data, is this line. So we're going to go across to this line, and then we're going to go down. And this is about 5, maybe a little above 5 centimeters per second. Now let's look at our choices. What choice is going to be close to that? And look, that's clearly the best one, 5.5 centimeters per second. So 27 is choice number 3. 28, which rock is classified as an evaporite? Here are your choices. Hopefully to this point you can recognize an evaporite is a sedimentary rock. So you go to the sedimentary chart. Hopefully that's something that you can recognize. So the sedimentary chart is here. In the comment section, you see the word evaporite. Let's zoom in. So it says, for these three types of rocks, they're formed of crystals from chemical precipitates and evaporites. And evaporites basically are when minerals that are dissolved in water, the water evaporates, and the rock it leaves behind is an evaporite. Okay, so that's these three rocks here. Now, if you look here, it does say the texture is crystalline. Okay, so your answer crystalline, and then of your choices rock salt. So your answer here is going to be number 4, crystalline rock salt. 29. Which pair of elements make up most of Earth's crust by volume? Volume is how much space it takes up. Compared to mass, which you'll consider to be weight, volume is how much space it takes up. You need to know that this is on the front of the reference table. We don't expect you to have this in your head. Look it up, front page of the reference table. Okay, and this is the crust of the Earth. This is by mass, and this is by volume. Let's zoom in. So, which two elements by volume? So be careful of this order. You got to look over here, and they kind of are not in order of highest to lowest here. So be careful. So what you're going to get is oxygen is 94% of Earth's crust by volume. Crazy. And then the next one here, the next highest one, is potassium at 1.42%. So the answer here is choice number 4, potassium and oxygen. Number 30. The cross-section below represents zones of soil labeled A, B, C. Letter D represents the underlying bedrock. So here we go. Bedrock is D. This is a cross-section as if you cut down through the soil. And it's asking which letter identifies the zone having the most organic and weathered material. So first off, organic, a little different meaning than what's in the grocery store. Organic means from a living thing. So in the soil, we mean decomposed leaves and roots and worm poop and things like that. And Up towards the top, you have more organic material. Down here, close to the bedrock, there's less because most of the life is close to the surface. You also have more weathered rock up here where the rock has been broken down more. Here you have larger chunks. This is more like sand, silt, and clay. Therefore, the answer is going to be choice 1A has most organic and weathered material. That comes up again and again. Know it. 31 looks very wordy, but we can do this. So, which type of surface bedrock is most commonly found in Utica, New York area? You know, you have to know that you have to go to the reference table. No one expects you to know this. So, first off, you need to go to this page of the reference table, Generalized Bedrock of New York State. Then you need to look around and find Utica. Okay? And it's going to be on there. It's right here. So what I'm going to do in this area, I'm going to zoom in on the map so we can see better. Here is Utica. Now, the type of bedrock, they have this sort of, this design represents different types. So here you have it's kind of annoying. It's like angled lines. That's straight lines. This angled lines, you have to look down in the key to see what kind of bedrock is in that area. So let's go to the key. Is again, Utica's here. You're going to go down to the key over here, and I'm going to zoom into that angled lines, which is going to be this bedrock here, sort of angled down to the right. And that the time frame, it forms an Ordovician, and what you have there, the types of bedrocks is limestone shales, sandstones, and dolostone. Hopefully you can recognize or use the reference table to realize those are sedimentary rocks. Therefore, the answer here is going to be, it's sedimentary rocks, and then it lists all of those right there. So 31 is choice number 1. 32, the diagram below represents a geologic landscape. Which type of stream drainage pattern formed on this landscape? So this is, if you look down from overhead, what would the streams or rivers look like based on the landscape here? Obviously water flows from high to low. Now this is a unique type of landscape. It's kind of have a cross section here too. So you see these kind of ridges. This is this dome and this differential erosion. And this is one of those where it's just a bit of common sense. You don't need to know the names of these. What you need to know is just match them up. And based on this, the answer is going to be choice number 1. This type of landscape is, stream drainage pattern is going to occur when you have a landscape like that. 33. The North Polar View map below shows the average area covered by Arctic sea ice in September 1980, 2000, and 2011. So this is one of those just looking at the maps, digesting it, and seeing what this shows, okay? Not necessarily doesn't require a lot of background knowledge so much, but so look at the key here. The lighter color is the ice and the white is the ocean. So look from 1980 to 2000 to 2011, okay? Look at the change here. You see the ice is shrinking. There's going to be less ice. Therefore, the question asked, the maps best supports the inference that Earth's climate is, and the answer is going to be 3. Warming, because the average area covered by ice is decreasing. So at the very least, you can narrow it down to 1 and 2 because it shows that ice is decreasing. And then it's sort of common sense to recognize that the warming causes the ice to decrease. So that is choice number 3. 34. Photographs below shows 2 depositional features labeled A and B. So this is basically erosion. So this is a feature A is all of this, and B is all of this. So they're really looking for the terms here. Which terms correctly identify depositional features A and B? Well, let's look at them a little bit. So this, if you step 1, 2, and 3, this is the formation of a delta. This is when a river brings sediment and deposits it into an ocean. And you see, so it's developing here, more deposition, and that's called a delta. Here is another example of a delta, the Mississippi Delta. This is it here as the Mississippi River flows into the Gulf of Mexico, brings so much sediment, deposits it there because the water slows down. So here's another example of a delta. Therefore, A right here is going to be a delta. Okay, now let's look at B. B is this elongated section of land right here. So let's look at this. What these are barrier islands, and this is formed by wave action, sort of like a sandbar if you've ever been to the beach, that will build up to be actual land. So these are called barrier islands. I think you have another picture here Long Island, New York. This is all barrier islands here. A is on a barrier island. So, and here's some more barrier islands here off the coast of North Carolina. Therefore, B is a barrier island. So A is a delta, B barrier island. That's going to give you choice number 1. 35. Diagrams A and B represent magnified views of the arrangement of mineral crystals in a rock before and after being subjected to geologic processes. Okay, so this is before, these are the minerals before, and then this is after. So the question asks, which geologic processes are most likely responsible for the banding and alignment of mineral crystals represented in diagram B? So hopefully you can recognize the term banding and mineral alignment to a certain type of rock, which is metamorphic rocks. And then also, hopefully you can recognize that when you have the metamorphic rocks, it is heat and pressure that causes the metamorphic rock to form. So you have pressure going this way, and it will elongate the minerals when they are partially melted. So that is choice number 2. Now we get into when you have a series of questions based on one thing, one diagram. So here, questions 36 through 39. Always read the top part here. It often has information that you need. On the graph below, in basic knowledge of earth science, the graph shows the observed water levels in feet for a high tide gauge located at Montauk, New York, on the easternmost end of Long Island from these dates here. Okay, so this is a graph, and this is a lot of just sort of reading the graph, interpreting the graph. So these are 2 days, and you see the water level goes up and down, and this is about tides. So this first question, which is 36, asks, what was the height of the water above average low tide level at noon on January 24th? So a pretty straightforward question. It is just about reading the graph. You don't need a lot of earth science backgrounds reading the graph. So let's find noon on January 24th. So that's going to be right there. So what you do is you go up to the line. What is the height of the water going to be? And then you want to go over to your scale on the left, and it's going to be there. And therefore, what you want to read this here. So this is 0. That's going to be 1 foot, 2 foot. You want to estimate that, which is your best choice there. And that's going to be choice number 2. 1.6 feet is your best answer. 37, still in the same graph. These changing water levels at Montauk can best be described as. So this is tides, and you see them going up and down. So these are some of our choices: cyclic and predictable, not predictable, non-cyclic and predictable, not predictable. Let's think about what the word cyclic means. Cyclic means a cycle of some sort of repeating pattern. Okay, and therefore the best answer is going to be cyclic and predictable. We can predict the tides because it's based on Earth's motions and the moon and the sun. This is something that is predictable. So choice number 1. 38, what causes the water level variation pattern shown by the graph? So you have to recognize that this is tides. It has the word tide in here. And you have to know what causes the tides. And here's an example here. So this is just a diagram that I have of what causes the tides. This is going to be the oceans on Earth. You see there's bulges here. It's because of the moon. It's the moon's gravitational force on Earth's oceans. That's what causes the tides. The sun a little bit too, but it's really about the moon, the gravity of the moon pulling the oceans towards it. That's the cause of the tides. So that's going to be, here we go, tides caused by the gravitational pull of the moon on Earth's oceans. Therefore, the best answer here is going to be choice number 4, Earth's rotation and the gravitational pull of the moon. And it's Earth's rotating as this is happening. That's why you have the tides change during the day. So 38 is number 4. .39. Here's the last question on this set of graphs here, and it doesn't have much to do with the graph. Check this out. It asks, what is the approximate latitude and longitude of the tide gauge? Well, this is where you've had to have read this, because look up here, it shows you where this is. It's on the easternmost end of Long Island, which is where Montauk is, but Montauk is not shown on the map. It's not labeled on the map. Okay, Montauk is right here. And let's zoom in here. So again, it's the easternmost end. So Montauk is actually right there. Hope you've been there. It's a cool place. I recommend you go if you haven't been. But so this here I drew in because you have the latitude, 41 degrees. I kind of drew this in blue, so that gives you an idea of the latitude. And then the longitude is going to be this line here. It's in purple going up and down. So Montauk is very close to the intersection of the 72 degrees west and the 41 degrees north latitude. So which choice is that going to be? It is going to be choice number 3. That one is a little bit tricky, so hopefully that really helped you show how you're supposed to get the answer on that one. Here we go. You use this for questions 40 through 42. The diagram represents some of the inferred stages in the life cycle of stars according to their original mass. So with all of these, you want to take your time, really digest the diagram, see what's going on here. And it shows star formation, and then it has the different paths: low mass, medium mass, and the most massive stars has the biggest, or have the most mass to them. They go in these different paths during their complete life cycle. 40, the final stage in the life cycle of the most massive stars is A. So what you want to do is you want to go here. The most massive will become here. It will become during a large star. So it goes this way. Then it becomes a supergiant. Then it has a supernova, and then it's either going to become a neutron star or a black hole. As the most massive stars is going to be a black hole. Therefore, that should be the answer. Choice number 1, black hole. So that's one of those things. You don't need to know it really. Just be able to use this chart, which is a common chart. You've probably seen it before. 41. Which star may once have been similar to our sun in mass and luminosity? Luminosity means how bright it is. Okay, really, if you could correct so they're all the same distance away, how bright they would be. That's what luminosity is. And this is all about the reference table. Okay, so you need to go to this is page 15 of the reference table, the star chart. Our sun is right there. Okay, so it is basically what you need to do is recognize that our sun is here. So what star of the ones that they list were once in this category right here? Okay, so this is what I'm going to do. Look at all of the ones in your choices. Okay, I circle them all here in red. So you have this is a white dwarf. These are supergiant stars here, and then this is also, these are like main sequence stars. All of these are main sequence stars. So what you want to do is, so the sun, what the sun does, the sun is going to become a giant star and then go here, become a white dwarf and a black dwarf. So one of these stars, either a giant, a white dwarf, or a black dwarf, was once like our sun. Supergiant, our sun's not going to become a supergiant. So that's important. Therefore, the answer you're going to get is going to be Procyon B. So if you look right here, Procyon B is a white dwarf. This over here is a little confusing, but this is a main sequence star. Therefore, that's the answer. Procyon B. 41 is choice number 3. 42. Energy is produced in the cores of main sequence stars when? Don't need the chart for this. This you have to know. Okay. So this is basically what happens. So you have stars start off as clouds of gas and dust. Gravity pulls them together, and then for them to be a star and give off all the energy, what causes that is nuclear fusion. You have to know that nuclear fusion. It's when lighter elements combine to form heavier elements. Different than what like nuclear fission. That's the splitting of atoms, and that's what we do at nuclear power plants here on Earth. But nuclear fusion happens in stars. That is the source of the energy. Their fusion elements are fused together. That's kind of what I used to help remember that myself. Fused together. And nuclear fusion is the source of all energy given off by stars. Therefore, the answer here is choice number 1. Lighter elements undergo fusion into heavier elements. Important to know. Make sure you know that. 43. Okay, so this is going to, you can use this to answer 43 and 44. The graph shows a number of radioactive isotope X atoms present as a sample of the isotope undergoes radioactive decay. So 43, based on the graph, the half-life of this radioactive isotope is, so you don't know what half-life is. Half-life is when half of the atoms that you start with have decayed and become the daughters. So first thing I want to do is say, we started out with 1,000 atoms, okay? So You get half-life is when you have half of that, which is going to be 500. Okay, so how long is that going to take? What you want to do is at 500, how long does it take? You go over to the graph and then you follow it down 3 hours. Therefore, it took 3 hours in this case for it to go from 1,000 atoms to 500. So the half-life here is 3 hours, choice number 3. And 44. 44 asks, based on the graph, what is the approximate number of radioactive atoms of isotope X that are present when 8 hours of decay has occurred? So this is just reading the graph. You don't need to have a lot of background information about radioactive decay. So what you want to do is, I'm zooming in here. So look at the scale here. I'm estimating 8 hours to be about here. It's not really in the middle. It's right about there. Then you want to go up to the line because the line gives you the information. Then you want to go over that way to there. So how many, what is this going to be? What's a reasonable number? Well, between 100 and 200, right around 150. Let's see where the choices are. Oh, I'm going to zoom in more. We had a better shot of it there. So right around 150. And therefore, the answer to that is number 3, 155. 45. In which temperature zone of the atmosphere is point A located? Here's point A right here. So you do need the reference table for this, but first thing you want to point out is this is altitude in kilometers, important, and figure out what that is. Well, A goes over to here, so maybe that's about 8 or 9 kilometers. So you need the reference table, and this is page 13 of the reference table. It's this chart. So what you want to see is the kilometer section of the scale, which is right here. So it's common that you get mixed up. Easy mistakes, don't do it. So we're interested in about 8 or 9 kilometers, somewhere in that range. Where would that be? That would be right about here, because this is 40, so these go by tens. So we're talking right about here, and then the blue line goes, this is the area of the atmosphere, that section of the atmosphere, and that is the troposphere, okay? So that's how you do that, and therefore it's going to give you choice number 4, troposphere. 46. The updrafts and the downdrafts represented within this cloud are primarily, which means mainly, caused by differences in what? So updrafts, you see the air moving up, and then in this case, the air is moving down right here. And key thing about the atmosphere is the movement of air up and down is usually always based on density differences. Low density air rises, denser air sinks. Okay, that is key. Therefore, that answer right there is choice 2 for 46, air density. 47. Which weather symbol would be placed on a station model to represent this weather event? This is key. What weather event is this? You got to look up here. It says it in the little description. A thunderstorm cloud. So which of these on a station model is the symbol for thunderstorm clouds? You need the reference table. Page 13. This is the station model section. And the weather symbols are here. So let's zoom in. Okay. Again, looking for thunderstorms. That's the symbol for thunderstorms right there. Which leads us to our answer of choice number 3. 48. 48 through 50 based on this diagram. Points on the map are surface locations. The dashed line represents a hiking trail. Elevations are in feet. So first question, 48. What is the contour interval of the map? Contour interval means what do these contour lines count by, or ISO lines count by? It is often given to you. In this case, it's not, so you have to count. One thing you can do is you can recognize this is the ocean, so this is 0, that's sea level, and this is 250 feet. Oftentimes, people kind of miss that. So you could just go 250, and that's 500. What do they count by? The one thing you can do is just kind of count them out. So let's just try to count by 25s. So let's try the first one. If that's 250, that would be 275, 300, 325, 350, 375. But that's not 375, can't be 25. Let's try the next one, 50 feet. 250, 300, 350, 400, 450, 500, that's 500. So therefore, it must be choice 2. Choice 2, 50 feet. 49. The gradient between location A and B is approximately what? So A is here and B is here. So gradient is going to be a calculation you'll do. It's going to put a number on basically how steep the land is here. And you're going to need, it's on the front of the reference table under equations. it is going to be right here, and that's where gradient is. It's change in field value divided by distance. Field value is whatever you're measuring. In this case, it's going to be elevation. And so one thing I want to say, elevation is kind of this. In this vertical direction, distance is going to be this way. I'm going to show you how to do it. So I put the formula here, gradient, change in field value divided by distance. So let's find the change in field value or the change in elevation between A and B. So there's A and B. And B has an elevation of 500 feet, A is 250 feet. So what's the change or the difference? Subtract that out. 250 feet is your change in field value here. That goes on the top of your formula. Now, to get the distance between them, between A and B, this way, okay, you need to use this scale. So it's easier to do when you have a piece of scrap paper and just a pencil sitting down at a desk. Harder for me to do on here, but I'm going to use, this is going to be my scrap paper, and I'm going to put it up here, okay? And then I'm going to mark carefully like the center of B and the center of A, okay? Hopefully you can see that, it's going to look like that. And then I put it up to this scale here. Maybe I'll even do it this way so you can see it better. And that gives me like right about that 10 miles. So they're 10 miles apart. So between here, they're 10 miles apart, and the elevation change is 250 feet in that distance. So let's do the math here. 10 miles. And then you do the math, what you get is 25 feet per mile. So for every mile, on every mile that you go this way, elevation is changing. It's going up by 25 feet. And therefore, that gives you answer choice number 2. 50. A person walks along the trail from C to D. The person will be walking how? Uphill, downhill, downhill, and uphill. Let's look at this carefully. So C, you start here, and you're about, that's 250, that's 300. So you're somewhere between 300, 350 feet elevation. As you go here, you hit 500. You're going uphill, okay? Hopefully you can recognize that these little circles here on the contour map represents the tops of hills, okay? So you walk up to the top of the uphill, and then you're going downhill because you're over 600 feet here, down to 500, below 500. So you go below 500, back up 500, 550, 600, then going back uphill. Okay, so take your time, go through this. So you're walking uphill, then downhill, and then uphill again. And that's going to be a choice, and that is choice number 4. Whew, that was a lot, all 50 questions. Thanks for watching. Keep studying. Good luck on the Regents.